definitely will get some 3D shape like complete face mechanism. Okay, here you will get complete surface here. Like this. Okay, so to control these kind of surfaces, we are using this profile of surface, and here we have to specify some tolerance value, so it will create one pixel planes here, so that the whatever deviations are there on the main surface, it should be lie between those two surfaces which we have given for the tolerance values. Okay, that is my profile of the surface. And the next thing is, this is my profile. The next one, what we have is location. That one, location tolerances or location profiles. So here we have first of all angularity. Okay, the first one is angularity. Seventh, I think. Yeah, angularity. Okay, so angularity means it is used to control the angles. Okay, suppose for example, if you have any object, okay, if you have any, for example, you will take an whole object. So here, for example, the holes are something like this. Suppose for example, this is my hole, and here we have some axis. Okay, this is my axis of the hole, for example. So to manage this axis, not only for this one, this is the example I'm giving here. Sometimes what happened, our face is something like this. Like this is the face. So here the angle of the object is little bit something like this. For example, 60 degrees or 50 degrees like that. So for example, what we have to do means here to control the angle here with this with respect to this one, what we are doing here, we are giving some tolerance value like this. Okay, some tolerance value I'm giving here. Between that one, if the object is deviating like this, it's okay, we can proceed for the production. Otherwise, we have to stop that one. Again, we have to do redesign of the component. Okay, that is my angularity thing. So one more thing is there in angularity. What I'm saying here, angularity is like that. Yeah. And see here, till now, whatever we have done here, we don't require any datum planes. But when we are doing angularity here, definitely we require datum. Why? Because for measuring angle, definitely we require datums here. Okay, for measuring angles, definitely we require a datum here. The symbol for angularity is, for example, not example, the angularity symbol is something like this. Like it will come in feature control frame, it will come something like this. For example, this is my feature control from Angularity, and here I am giving like this tolerance. Angularity symbol is this one, and tolerance value I'm giving 0.15 for example. And here definitely we have to specify the data. Without data, we can't able to give here angularity. For angularity tolerance, definitely we require data. Why? Because we require some difference to measure the angle. So compulsory we require the data here. The next one we have after angularity, we have parallelism. Eighth one is parallelism. So in parallel, the symbol for parallelism is something like this. Okay. and the feature control freedom will be appear something like this. First of all, what happened here, it will come the gradient symbol, parallelism. Here we have to specify the tolerance value, and here we have to specify datum. So see here, for compulsory orientation purpose, definitely we require the datums here. Why? Because suppose for example this is my object and I want to see these two lines. For example, these two lines are parallel, for example. So parallel with this one means it should not come exactly parallel to this line. So at that time some deviations will come. To avoid those deviations, what we will do, we will keep some parallelism tolerance value here with respect to this plane. Okay, with respect to this plane, we are giving the tolerance value for the parallelism. Okay, that is my parallelism tolerance. The next one we can find here is perpendicularity. Perpendicularity, the symbol for perpendicularity is something like this. This is the perpendicularity symbol here. So in datum feature control frame, it will come like this something. Here it will come the perpendicularity symbol, and here it will come tolerance value. Datum required. But this one also will require datum. Why? Because for example, I have the same object like this only, same like angularity only. What happened here? This is my datum. From this one, the object should be perpendicular. For example. Okay, datum, and this is my perpendicular face now. So control this thing, what we will do, we will keep some angle here. So if it is coming deviation something like this, means if we are getting the angle of 90 plus 0.25 also, it is okay for us. It will get the pass in our test. So like that we will get the perpendicularity also. Okay, that is my perpendicularity. The next one is perpendicularity. After this is your orientation. The next one is location tolerance. So location we have, the first one is symmetry. Okay, the first one is symmetry here. The symbol for symmetry will be something like this. Okay, the symbol for symmetry is like that, and it will be appear in control feature control frame will be like this something. Okay, here we have to specify tolerance value. Here datum will not be exactly that you have to place datum. It's your choice. It when required you have to give datum. If it's not required, means you don't require any datum. So it's depend on our requirement. Datum symmetry. Okay. So how it will be, means suppose for example this is your object. Okay, this is symmetry object. I have to divide this object exactly symmetry about this axis. So what happened? It will come a little bit somewhat tilted here like this. It will tilt sometimes. Sometimes it will tilt like this. Sometimes it will tilt like this. So if you are giving the tolerance value between that, if it is tilting means nothing is happening. So this tolerance we have to give with the help of symmetry object. Why? Because we are taking this as the references for you. So here we can to keep the tolerance value. If it is coming in between the tolerance value, means we can accept this value. Okay, that is symmetry. The next one is this is the 10th one. Now the next one, 11th one. Next one is symmetry, position, concentricity. The next one is concentricity. Okay, concentricity, the symbol for concentricity is just two circles are there. The actual meaning of concentricity is two circles having same center. Center should be same, but the radius and diameter will be different here. That is my concentricity. Okay. So like that concentricity will define here. So it will be appeared in the feature control frame something like this. It will come here. Here we get this of here to give concentricity symbol. This is my concentricity. Here it will come the tolerance value, and here we will get the datums if it requires. Okay, here also if it requires, we have to give the datum here. So concentricity means it is same like that only. Suppose for example I have one hollow shaft is there. Take one hollow shaft here. Okay, take some hollow shaft here like this. For example, this is my hollow shaft. The center of this first circle will be here. Second will be here. Okay, if it is lying between these two thing tolerance value, if it is lying in the tolerance value here, then it will be accepted. Otherwise, we have to create this object here. So concentricity means the center will be lying under the limit only. So then only we can able to specify this concentricity value here to avoid these deviations. And the next one is position tolerance. 12th one is position tolerance. The symbol for position tolerance is a little bit like this. This is the position tolerance symbol. Okay, this is the position tolerance symbol here. So this is a very important why, because for locating dimensions, okay, for locating dimensions, for positioning the holes or positioning shafts on the particular object, this requires a lot here. Why? Because see here, for example, first of all, which is the feature control frame for this one is the feature control frame. Here, this is symbol. It will come here, for example. Like this feature control frame, then diameter it will come or not, it's depend on our requirement. 0.25 tolerance I am giving here, and definitely we required. And one more thing will come here, that is your modifiers based on the requirement. Modifiers. Then the next thing it will come here is datums. Okay, datums will come here. Okay, now see here in the position tolerance, what happened is, suppose for example, I am taking an example of hole here. Suppose for example, this is your sheet. On that sheet, you have one hole here. Okay, this is your hole. I am doing zooming of this one, so it will come a little bit like this. This is your hole, for example. Okay, see this is your position tolerance. Now, so in that one, we have to position our object here. So, suppose for example, this is my center of the hole. What happened if I am giving the locating dimension for the center of hole from the corner edges? This is specifying the tolerance also. For example, this one is like 10.05. This is also like 10.05. So here 0.5 extra, that is your tolerance. So what it will do, 0.5 it will make like a square shape like this. for the center. Okay, 0.5, 0.5 came like. So what happened here? This way I will go for NX to show that sketch to you how it will come. So 0.5 tolerance will come here. So what happened here? See, this is the hole. Here what I am giving 0.5 tolerances I am giving here. So how it will become? Center rectangle I will take from here to width I am giving 0.45. This one also I am giving 0.45. Okay, like this. So what happened here? In between this time, if the center will come anywhere, it will act acceptable for you because of the tolerance you have given them. See here, what happened? If I create a circle here of radius 0.05, go for here like this. Okay. Now see here what happened. The same tolerance value, if you keep to the help of position tolerance, see here, what time you have given directly. This is a traditional method of giving tolerance, which we are not using that much here. Here also we will specify the tolerance, but it will not that much effective than this GD&T symbols. Okay, if you give like that, means we create some square box. So in between the square box, it will come. What we can say, we will get here tolerance value here. Wherever center is coming with square bracket will acceptable. If it is coming little bit outside, where it will affect your geometry. For example, if it is coming somewhere here, the center of the circle, it will affect your geometry here. It will not accept this thing. So if you give the position tolerance here like this, so see here we are getting some extra space for the geometry, so that it can locate our center of our circle or hole here. So for that reason, we are avoiding this traditional method of giving tolerance, and we are accepting this position tolerance. Why? Because here we are getting some extra space for the tolerance value. Okay, that is the position tolerance option here. Okay, like that we will specify the position tolerance for our geometry. Why? Because position tolerance always come with the diameter value. I am not giving here. Here I will give. It will come always with the diameter. Okay, position tolerance will always come with the diameter value. This is the position tolerance. The next one is your runout. Runout. 13th one is runout. Okay, 13th one is runout. The symbol for runout will be something like this. Okay, the symbol for runout is something like this. This arrow mark. Okay, it is only for the rotating shaft, not only for rotating shaft. It is for rotating shaft. Suppose for a shaft is rotating under the any assembly, so due to vibrations, the object will get touched to the other face of the geometry. So while rotation, it will generate the vibration also. So due to that vibrations, the deviations, whatever you are getting on the particular shaft, so that deviations we can able to connect with the runouts and total runouts. If it is a circular, if you are seeing that thing in a circular manner, so then that is we can say as a runout. If you are seeing like a cylindrical manner, then it is come like a total runout. It is same like circularity and cylindricity, but the difference is there you cannot find any vibration. Directly the manufacturing only we are checking there, but in runout we can check completely the vibrations also. Due to vibrations also, whatever changes you are finding here, that thing also we can able to see here. The last one is total runout, 14th one. symbol for total node is something like this. Okay, symbol for total node is something like this. So it is for cylindrical objects. So it will control both circularity as well as cylindricity of the object here. Okay, so like that, for modifying, for giving like those kind of things, we are using this GD and D symbols. The last thing which remain here is the modifier which we are using here for representing something. So what is modifier here? There are two types of modifiers here. Modifier, the first one is LMC, which means least material count. MMC, the next one is MMC. Next one is MMC, which is meant by maximum material least material count, my maximum material count, MMC, LMC. And the last one will get here regardless feature size. Usually we are not using any symbol for that one. Yes, which we can say as a regardless feature size. Here we are not using any symbol for regardless feature size. Like yesterday also I shown you in the GD&D basics, that is, it's given some note there. See, second rule number 2 only, that for regardless features we are not specifying any symbol. If there is no symbol here, see here you are seeing the M symbol, now that means your modifier is giving to the tolerance. But if it is not giving anything, means it comes under regardless feature size. So default it will come, that one should, that one only. LMC symbol will come something like this. Okay, one circle is there, under that one you can find one letter, that is L. This is your least material condition. That is your maximum material condition. Regardless, it doesn't have any symbol here. So what is LMC and what is LMC? For example, I have two objects and two things are there, two features are there. One is shaft, another one is hole, for example. Okay, two things are there. The diameter of the shaft, is 10 mm. Okay, and the hole is also 10 mm. This is your hole, this is your shaft, for example. Okay, what happened here? I have given the tolerance value like plus or minus 0.5. Here also plus or minus 0.5. Like that, I have given the tolerance value. Okay, now so what is maximum material condition? Maximum material condition in the sense the maximum amount of material present on the object after surface finish or after doing your production work. What is the maximum amount of material will be present on the object? That is my maximum material condition. And what is the minimum amount of material present on the object? That one we can say as a least material condition. Okay, not count, it is condition. Sorry, least material condition. And this is also maximum material condition. Sorry, not count. Okay. Now say here, what is the maximum material condition for shaft? Means 10 plus 0.5 is equals to 10.5. It will become like this. If you do 10 minus 0.5 is equals to 9.5. Okay, then come here also 10 plus 0.5 for whole. It is like 10.5 and minus minus 0.5 is 9.5. Okay, so maximum material condition means when shaft has maximum material. When the diameter is bigger, then only we can say there is a maximum material condition. Okay, so here for shaft maximum material when it will be there means when the shaft diameter is bigger, and least material will be this one. Why? Because here we remove so much material here, so that it has the least material condition. But it is different in hole condition. Why? Because if the diameter of the hole is bigger means there is less material present on the object. So this will become your least material condition, and this will become 9.5 means the diameter is smaller means the object has more material. So then we can say that is my maximum material condition. Okay? So like that we can do the things here. Understand? These is some basic things in GDL.
Okay, sir. Okay, sir.
Okay, sir. Okay, sir. Okay, sir. Any doubts?
No, sir. No, sir.
No, sir. Okay, then fine. So if you are getting any doubts, you can just ping me. I will arrange one class and I will explain this again. Okay?
Okay, sir.
Okay, sir. Okay.